Hello students, welcome back to our new video. In this video, let's talk about continuity. This is the normal definition. A function is said to be continuous function if and only if the graph of the function can be drawn without lifting the tip of the pen. For example, y equal x. Let's draw the graph of y equal x. It's a number line, and this graph is drawn without lifting the pen. So this function is continuous function. This is x, this is y axis. This line is y equal to x. Next, second definition, continuity of a function at a point. How to check a function is continuous at a particular point, x equal to a or b? First, let f be a real function, real valued function. Then f is said to be continuous at a particular point, x equal to a, if limiting value is equal to functional value. Limiting value means limit x tends to a f of x. This is also called approaching value, and this is functional value f of a. If these two values are equal, then the function is continuous at this point, x equal to a. Then second point, this limiting value is exist if left hand limit is equal to right hand limit. What is left hand limit? Limit x tends to a minus. A minus means here the value of x is less than a. Here the value of x is greater than a. If these two values are equal, then limiting value exists. If this limiting value is equal to functional value, then we can say that the function is continuous at this particular point, x equal to a. If these two values are not equal, then f is discontinuous at x equal to a. These are the few examples. Now we will discuss from question number 1. First question number 1. F of x equal to f of x equal to 1 by x at x equal to 0. Check. At this point the function is continuous or not. Limiting value. Limit x tends to 0 f of x. Limiting value is exist when left hand limit is equal to right hand limit. First we will find left hand limit. Limit x tends to 0 minus f of x is 1 by x. Here x tends to 0 plus 1 by x. Now put the value of x. What is the value of x? X is tends to 0 and x is nearly equal to 0. Now put x equal to 0. It is 1 by 0 minus undefined. Why minus undefined? Because x is less than 0. It is a negative number, and here 1 by 0 is n. You can write 0 minus also. Here x is greater than 0. It's a positive number. 1 by 0 is undefined. In these two values are not equal. Here in undefined, here also minus undefined. Limiting value does not exist. When limiting value does not exist, that means it is not equal with functional value, hence not continuous. Now second question. Second question is given that f of x equal to greatest integer function. F of x equal to greatest integer function at x equal to 2. Limiting value and here functional value. If you want to find functional value, simply put x equal to and greatest integer of 2 is equal to. If you doubt in this function, go to the previous video of function and check out definition of greatest integer function. Limit x tends to 2. Here also left hand limit and right hand limit. This is left hand limit, x tends to 2 minus greatest integer of x. X tends to 2 minus means x is less than 2. Less than 2 means x is nearly equal to 2. That means x equal to 1.999 or x equal to 1.998 like this. If you want to find its greatest integer, what is the greatest integer of 1.999? This is equal to 1. In this case, this is 1. And what is x greater than 2? X greater than 2 means x equal to 2.0001. And what is the greatest integer of x? 2.001. This is equal to 2. Hence, left hand limit is not equal to right hand limit. Limiting value does not exist. Hence, this function is not continuous at x equal to 2. It is discontinuous function. Next question, question number 3. We have to check this function at x equal to 0. First, functional value. At x equal 0, when x is equal to 0, f of x equal to this much. Now put x equal to 0 here. 3 plus 2 times 0, answer is 3. Then we will find limiting value. Limit x tends to 0, f of x. X tends to 0 means first we will check left hand limit, then right hand limit. Left hand limit means x tends to 0 minus. Here limit x tends to 0 plus. X tends to 0 minus means x is less than 0. When x is less than 0, f of x equal to 3 plus 2x. So write here 3 plus 2x. What about x tends to 0 plus? In this case, the value of x is greater than 0. X greater than 0 means f of x equal to 3 minus 2x. This is 3 minus 2x. Now put x equal 0. From here we will get the value 3. From here also you will get the value 3. And here both are equal. Hence limiting value is equal to 3. And function value also 3. This is equal to functional value. That means it is a continuous graph. Last question, check continuity of the function f of x equal to mod x. First, simply draw the graph of f of x equal to mod x. If you draw the graph of mod x, so this is x, this is our y. Put x equal to 0. What is the value of y? 0. Put x equal to 1, 1. Put x equal to 2. If you put minus 1, it is 1. Graph is like a V-shaped graph. Starting from it is 1, it is 1. Point is 1, 1. It is 2, it is 2. Point is 2, 2. If you minus 1, this is 1. Point is third point. You can draw the graph without lifting your pen. Hence, it is a continuous graph. Or you can do this graph using left hand limit, right hand limit and functional value. Properties of continuous function. First property, every constant function is continuous. Remember that. Second, if f is a function, g is another function, and both are continuous at a particular point, that point is fixed or same, that point is same, it is x equal to a. If both are continuous, then first bit, addition of f plus g is also continuous. Multiplication of f into g is also continuous at that particular point. Suppose it is x equal 1, then it is also continuous at x equal 1, not x equal 2. We cannot say it is continuous at x equal 2. Then f by g is also continuous provided that this term is not equal to 0 at x equal to a. If this is equal to 0, something by 0 undefined, it is not possible. Next, k times f is continuous. What about k? K is a constant quantity. Similarly, we can show that f minus g is also continuous at x equal to a. Next, every polynomial function is continuous. Polynomial function means x square plus 2x plus 5, it is a quadratic equation. X square minus 1, x cube minus 4, it is a cubic equation. Every polynomial function is continuous everywhere. Next, every rational function is continuous in its domain. And every exponential function e to the power x, e to the power x, e to the power 2x is continuous. Next, trigonometric function sin x and cos x. These two functions are continuous. The rest are discontinuous function. Only these two functions are continuous function. What about other functions are cosec x, sec x are discontinuous function everywhere, but they are also continuous function in its domain, respective domain, not everywhere. These two functions are continuous everywhere, and other are discontinuous function and continuous in its domain only. Next question, the relation, find relation a and b so that a function is continuous at x equal to 3. First, find functional value. Functional value means x is equal to 3. This is the case, equal case. F of x equal to ax plus 1. Now put x equal to 3, 3a plus 1. Then find limiting value. Left hand limit, x tends to 3 minus. 3 minus means this case ax plus 1. X tends to 3 plus, greater than 3. That means bx plus 3. Now put x equal to 3. This is 3a plus 1. This is 3b plus 3. The function is continuous. That means left hand limit equal to right hand limit, that is limiting value, equal to functional value. 3a plus 1 is equal to 3b plus 3 is equal to 3a plus 1. And a equal to b plus 2 by 3. This is the relation between a and b. Next question, find the points of discontinuity of the function f of x equal to x square minus 1 divided by x square minus 5x plus 6. How to find? This function is discontinuous when this is equal to 0. When lower limit is equal to 0, something by 0 undefined. That means when this term is equal to 0, function is undefined. This is equal. Now simplify it. You will get the value of x. X equal to 2 and 3. In this point, this polynomial function is discontinuous. Now back to our property. Every rational function is continuous in its domain, and this is a rational function, not polynomial function, sorry. This is a rational function, and this rational function is continuous in its domain. In these 2 points, the function is not continuous. That means domain of the function is r minus 2, 3. And in its domain, this rational function is continuous. And at this point, this function is not continuous, discontinuous. And discontinuous also 2 types. Discontinuous are 2 types. One is removal and another one is non-removal. In the upcoming video, we will discuss about these 2 points. and these two words, removal discontinuity and non-removal discontinuity.